Good day, everybody. Today what we're going to be looking at is how to interpret quadratic word problems when they are in factored form. We have a problem here where an object is launched from a platform, and it's given by this function right here. And the question says, what is the height of the object at the time of launch? Alright, so what's the height at the time when it's launched? So when it's launched, basically, that's where the time is equal to 0. Time equals 0. And since x is seconds, what we can do right here, if we're going to do it by hand, we'd plug in a 0 right here, and we'd plug in a 0 right here, because at the time of launch, your seconds, there are 0 seconds. So here's what it would look like if you do it by hand. You do -5, open up parentheses, 0 plus 1 is 1. 0 minus 9 is -9. Then we multiply everything together. -5 times -9 is a total of 45. And so we would say it was 45 meters high on the platform at the time of launch. Right? You could also type this into Desmos and take a look at it. So here's our picture in Desmos. Just typed in the function notation, that's h of x, that's the same as y equals. Alright, you'll notice right here it has certain points that just pop up on the screen. We have 0, 45, that's your y-intercept. We have 4, 125, that's known as the maximum height. That is our vertex. And right here, this 9, 0, that's called a 0, also known as a root, a solution, which is considered to be one of the x-intercepts. These are all words that mean the same thing. Okay, that's one of the x-intercepts. The other one is over here at -1, but that doesn't make sense because you really can't have negative time. Alright, so our 0 basically means at 9 seconds it hits the ground. Alright, so right here we consider this to be the ground level. Alright. So that's 9 seconds. Our platform height is 45, and our maximum height is 125 meters. And if they asked us how long did it take us to reach the maximum height, the answer would be 4 seconds. But ours is pretty easy. It just says, oh, and on Desmos, if you don't see the points, just click on the graph, and you'll see certain points pop up. There's one of the zeros, there's another 0, there's the y-intercept, and there's the maximum. You can find those points pretty easily. Alright, so let's go over here. Let's type in 45. Hit check. Let's go to the next question. Alright. Oh, interesting. Looks like we have the same equation, just a different question. Alright, so it says how many seconds after launch will the object hit the ground? Well, that's pretty easy. If you look at our graph, we already have it right here. It's going to hit the ground after 9 seconds. Alright, so I'm just going to go over here. Type in 9 seconds. That was easy. Alright. Alright, let's do a couple more questions just to kind of get the hang of it. It says, Ricardo throws a stone off of a bridge into a river below. The stone's height in meters above the water, x seconds after he threw it, is modeled by this expression. So this is w of x. So I'm going to go ahead and show you guys how to do this by hand. So basically, we're going to have the same type of problem. I'm just going to make a quick little sketch. Here's the x-axis, there's the y-axis. Alright, so basically what's going to happen is Ricardo's somewhere on a bridge, he's going to throw the rock up, it's going to get up to its maximum height, and then once again it's going to fall to the ground. Okay? This section we really don't have to worry about because that's where the x's are negative. Here's your x-axis. We'll call this w of x, which represents in meters. So this is meters. Alright, so here's how you would do it by hand. It says, what is the maximum height? So the first thing we do is we find our two zeros. And to find our zeros, we figure out what number would be plugged in there to make it equal to 0. Well, the number 8. 8 minus 8 is 0. -4 plus 4 is 0. Alright, so I have two of my zeros. No, I got an 8, 0, and I also have a -4, 0. So right here, I know right here, I've got an 8, 0, and over here, I've got -4, 0. Now something we learned yesterday, well, or not yesterday, but the previous video, the axis of symmetry always passes through the vertex, and it's perfectly straight in between the two zeros. It's like it's halfway between the zeros. I'll try to do a better job of drawing an axis of symmetry. That's horrible. Still bad. Come on, here we go. Eventually, just have to start this whole video over again. Alright, that's a little bit better. That's a little bit better. Alright, so let's check it out now. If we have negative 4 as one of our zeros, and we have 8 as the other zero, we add them together. Negative 4 plus 8. You all know that's 4. 4 divided by 2 is 2. So what does that mean? That means we have an axis of symmetry at x equals 2. So what is this line right here? That's what we call the axis of symmetry. That's at x equals 2. And that right there, that point right there, will help us find our vertex, which happens to be the maximum height. Alright, so what are we going to do with this wonderful 2? What I'm going to do is I'm going to erase these guys. Going to plug in a 2. Going to plug in another 2. And I'm just going to work it out right here. I got a negative 5. 2 minus 8 is negative 6. 2 plus 4 is positive 6. Alright, negative 5 times negative 6 is a total of 30. And 30 times 6 is 180. So what does that mean? That means after 2 seconds it reaches a height of 180 meters. Wow, he's got quite an arm there. Alright, so what's the maximum height that the stone will reach? 180 meters. Now we're going to go and type this into Desmos. Alright, check it out. We got negative 5. Here, I'll even show you. You can even change the H to a W. It's not going to matter. Alright, let's go down here and check this out. It says x minus 8, x plus 4, x minus 8, x plus 4. Now we're going to have to zoom out quite a bit here, but you can kind of still see. You still have, that's where it hits the ground. There's the bridge. That's at the time of launch. It was at 160. Oh, never mind. He doesn't have that good of an arm. He only threw it 20 meters high, so it's not that big. Not that big of a deal. But it did reach a height of 180 meters. All right. So I'm just going to type in what's the maximum height that the stone will reach. 180. But he was already 160 meters up. So sorry, Ricardo. You really don't have that great of an arm. All right. A hovercraft takes off from a platform. What is the height of the hovercraft at the time of takeoff? Well, once again, that's going to be dealing with the y-intercept. At the time of takeoff, always deals with the y-intercept. So once again, quickly, how would you be able to do that by hand? All you got to do is plug in a 0 and plug in a 0 if you're dealing with the height at the time that the hovercraft takes off. So this is going to be pretty easy. Negative. Now, if you want to, you can obviously use Desmos and plug it in. I'm just trying to show you how to do it by hand. So we get negative, we got a negative 11, and we got a 3. The negatives cancel out. We multiply it together. We get 33. And once again, not too difficult if you know what the question is asking you to do. All right. How many seconds after takeoff will the hovercraft land on the ground? So right now, once again, this is dealing with one of those problems where we are looking at when it hits the ground. Like this hit the ground after 8 seconds. This hit the ground after 9 seconds. All right, so we're looking for the zeros is what we're looking for when it's asking for when did it hit the ground. So how many seconds after takeoff will the hovercraft hit the ground? So what are we looking for when it says that? We're looking for the zeros of the function. Well, this only has 2 zeros. What number would you plug in there to make it equal to 0? 11. What number would you plug in there to make it equal to 0? Negative 3. Now, which would make the most sense? After 11 seconds it'll hit the ground, or after negative 3 seconds will it hit the ground? I'm going to go with after 11 seconds, since we don't have a time machine and can't go back 3 seconds for it to hit the ground. Alright, so all I'm going to do is over here, type in 11 seconds. Alright, and hit check. Alright, so now you're going to have one of those types of questions. It could be, we're going to go and type this in. I'll make sure you know exactly what it's going to be asking for. You could have another hovercraft problem, but the answer may not be 11. It may be a different answer. So let's type this in real quick. We've got, let's see here, we've got h of x, so I'll even change it up. That's just function notation, it just has a negative. It had x minus 11 and x plus 3. You should be able to, if you can't see the graph, if you just zoom out enough, right here, hit this little zoom out button, you can be able to see it. It shouldn't be that hard. Once again, we're going to go over this point. At the time of takeoff, it was 33 meters high. After 4 seconds, it reached a maximum height of 49 meters. And after 11 seconds, it hit the ground. So once again, that's your y-intercept, that's your maximum. That 4 represents the seconds that it takes to reach its maximum height of 49 meters. And after 11 seconds, it hit the ground at 0. Alright, hopefully this will be helpful when you guys are working on this assignment. You all have a wonderful day.